How to find the empirical formula. Okay, so let's consider the question. A sample contains 1.1 gram of nitrogen. Then I made a small mistake here, but it's actually 0.161 grams of hydrogen, then 0.48 grams of carbon, and 0.64 grams of oxygen. And then they ask you, what is the empirical formula? So how I like to approach such questions is to make a table, okay? So in the table, you would include all of the elements that you have. So your first one would be nitrogen. Okay, the second one would be hydrogen. The third one would be carbon. And the last one would be our oxygen. Okay, so then you made our little tiny table. Okay, so this is the table. So first you have to work with what we have. And we are given to all of our elements, then we have mass. Okay, so we would obviously start working with mass. Okay, so let's first really slowly write down all the mass that we know. Okay, so for nitrogen we know it's 1.12. This is going to be in grams. Okay, for hydrogen we know it's 0.161. For carbon, we know it's 0.48, and for oxygen, we know it's 0.64. Okay, so then we have to write, so this is going to be like a sort of a formula that you have to remember. First, you have the mass, and always when they ask you questions like this, always try and find the number of moles. This is your number one, like you have to find the number of moles. Number of moles is what you need to find. And how do we know from previous knowledge? We know to find the number of moles, we need mass over MR. So we have mass is sticked out, and we need MR. So it's not difficult, you just look at the periodic table, and you know that nitrogen is 14.01. This is in gram per mole. Okay. Then you know that hydrogen is 1.01, carbon is 12.01, and oxygen is 16.00. Okay, so we already have these two. So now let's find the number of moles. And you do number of moles by dividing M by MR. Okay, so we divide this by that, like that. Okay, so you just do the calculations in your calculator, and you would receive then 0.0799 moles. Always forget to write that down there. And then you receive for this one 0.159 moles. Here you would get 0.040 moles, and here you would get 0.040. Okay, so now what you have to do now, this is the most important step, and this is your step 4, which asks you to divide by the smallest, because you need to find the ratio. Okay, so you need to divide by the smallest. Okay, so let's find the smallest one out of this one. This is pretty small compared to this one, so this is already not the smallest one, and these two, I guess you would just divide by that one. That's the smallest one. Okay, so you divide this by that, and you would receive here 2. Here you would receive 3.98. Here you would get 1, and here you get 1, because you divide them by 0.004. Okay, so this is your first step done. And then you need to now basically near it to the whole number ratio. Okay, so near it. And how you would do that, so this is simply 2. This is obviously going to be a 4 because you have 9/8 after the comma, after your point, and then this would be 1 and this would be 1. So you are left with these numbers. And these are the numbers that you need. So you have 2 for nitrogen, so you just write it down. So you have your empirical formula would then be 2 for nitrogen, so you write N2. You have 1 for hydrogen, so you just write H. 1 for C, so you just write C. And 1 for O. So this is going to be your OH. That was a 4, sorry guys. You write a 4. I messed it up a bit, but this is basically your empirical formula. Your empirical formula is N2H4CO. So this would be your answer. See, you just have to remember the pattern. So first of all, always find the number of moles. This is the most important thing, number of moles. Divide with the smallest and near it, and this is how you get your empirical formula.